immediately you will get the result and it will be there in your mind forever. Okay, but the thing is you have to follow intensity due to an infinitely long charged wire. Okay, so this is what we are going to find out. It's very simple derivation. Consider a wire of infinite length. This is very important, the consideration, okay? Infinite length with charge density. Wire means what kind of charge density? Linear charge density, lambda. Okay? Charge density, Q, lambda, that is you can write it here. Lambda is nothing like what? Q by L. Infinite length, you can write it L as here. Okay? As shown in figure, that's it. So consider one thing. This is your thing, right? Plus, 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 plus. Okay. Now what you have to do? Consider a point P at a distance R from the wire. Anywhere you can take it out, not an issue. Consider a point P such that OP equal to R. Minimize your writing. Okay? OP equal to R. So what is the next step? You have to imagine a Gaussian sphere. Okay? Consider or imagine a Gaussian surface of radius R and height H. Okay, I am going to consider cylindrical Gaussian surface because it will be easy and it is given in your book also. So we need not break our head to use. You can use spherical. You can use some other thing also. But it will be easy if you follow this. Okay. Consider a imaginary Gaussian cylindrical surface. Okay. Of radius R and height H. So now next step is what? You have to find the angle between electric field and area vector, right? First I will let us know that area vector, how to calculate. You know cylinder, we have discussed it. So this is phase 1, this is phase 2, this is phase 3. Two flat faces and one curved face. The phase 2 is curved. And 1 and 3 are flat circular. Okay, so where is the area vector? First draw the area vector for this. The area vector for at this point P, if you take it, it will be, where is the area vector? Area vector in this way, right? And what is the area vector for this? You consider any surface element and then find, not an issue. You need to know the area vector throughout the surface. One element, if you find, it is enough. For this one, it will be pointing this way, closed surface. So only outward electric flux is allowed. All the three phases we have found out the area vector. The next, find the direction of electric field. For finding the direction of electric field, always remember, okay, this is the linear charge distribution. Okay, consider this point P at this point. Consider from this point equal distance you take. Okay, AA. From the point O, you take equal distances. And consider, due to this charge, what is the electric field at this point P? Positive, positive. Whenever you need to find electric field intensity, you will place a unit positive charge at that point. Now this is positive charge. The electric field will be this way. And similarly, due to this charge, what will happen? The electric field will be this way. Since the distances are equal, what will happen? This will also be equal. So now it is making an angle, okay, with the y-axis. Or you know that already we have learned this. I need not remind you. But still, you know that this magnitude will be equal because these two are separated by the same distance. The magnitude EA, if I consider this point as A and this point as B, so EA will be equal to EB when two vectors making an angle theta with each other. Two vectors of equal magnitude making an angle theta with each other, then the resultant vector will lie in the midway. This is the net resultant vector. Oh ma'am, forgot. Okay, let us consider this vector makes an angle theta with the y-axis. Then what you will do? You will resolve this vector into two components. This one will be theta nearby, so E cos theta. This one is E sin theta. Similarly, here what you will do? You will resolve this into two vectors. This E B cos theta, and this one is EB sin theta. The sin theta cancels. Only E cos theta component will contribute. Since EA equal to EB, the net electric flux will be what? It will be 2E cos theta. This is due to one element from this side and that side. Similarly, there will be number of elements, right? For each element you can take this way. Yes or no? Or due to this charge, due to this charge. At this point, if you want, then you consider from this charge, this one, this charge, this. Like this, you can consider for infinite number of elements. But what is the net result? That is what I need. Where the electric field will be. So if it is a line charge, where the net electric field will be, in all the points it will be pointing this way only. If this is a charge where it will be, there are no, all other components will cancel each other. Is it clear, ma'am? Everyone? So how yes, the electric field, if you take one charge, electric field can travel in this way it will be there, this way it will be there, this way. Like a sunflower petals, how it will be arranged. That way the electric field can go outward. You cannot draw an electric field. Two dimension, I cannot show it. It will be like this. No electric field can be placed because it will get cancelled by the other component. Is it clear or not? Whenever I talk about linear charge distribution, only I will talk about this way. So for this surface, where the electric field is possible, the electric field will be pointing outward. So what is the angle between electric field and area vector? It is 0. And here also the electric field will be in this direction only. What is the angle between electric field and area vector? It will be 90 degree. And the top also, the electric field is in this direction and the area vector is in this direction. So theta will be 90 degree. Now tell me, the net flux is given by what? Net flux is given by integral E dot ds, opposite surface integral of E dot ds. That is nothing but what? It is due to what? It is due to T components, that is phi 1 plus phi 2 plus phi 3. So for each one you find it out. What is phi 1? Integration of E dot ds is due to phi 1. Then integration of this is due to 2. Don't write phi, just write 1. Represent it is due to the first phase. This is second phase. And this is the third phase. Surface integral, right? Any doubt you can let me know. Okay, so what is this? Here substitute this EDS cos, what is the value? 90 degree for the first phase. For the second phase, it is EDS cos 0. And for the third phase, it is EDS cos 90. Is it clear or no? So cos 90 is 0, so this will become 0. Cos 0 is 1, so this will become E dot EDS, and here it will become 0. So the net electric flux will be what? Integration of EDS. But E is constant because the radius is constant throughout that cylinder. So E will be constant. You can keep it outside. And the integration of ds. Integration of ds is what? I already told you. Integration of dx is x. So if you are doing the integration of surface, then it will give you what? Yes. Yeah. Or you write it down. The entire surface area. What is the surface area of the cylinder, ma'am? Surface area of cylinder. Here, which face is in consideration? Curved surface. Flat surface is eliminated. So now curved surface. What is the area of curved surface? 2 pi RH. So that value you have to substitute here. So this is the net electric flux. Is it clear or no?